I'd like to talk briefly about the different types of correlations. And one of the things I'm going to do in this is I'm going to come back to a chart that I shared in the written work for this, or the printed stuff for this, stuff I put in words. It's not actually printed yet. Maybe it's printed. Um, in this week's readings, anyway, there's this little chart, and it's an important one to some extent. Um, Usually when people say, go find find the correlation between these things. What people are talking about, like they say that like there's one kind of correlation. There's one way to find a correlation. Well, mostly what they're talking about in that process is what they call the Pearson's R. And that's the correlation between two sets of interval or ratio data. And that's the one that's used most commonly. And I'm going to do another short video here walking through the mathematics of that, but that's not this video. On this video, I just want to talk about the different kinds. In this course, all we're going to work with are the Pearson's R. However, there are other types of correlations. And if you try and use the Pearson's R correlation with other kinds of data, you'll get something that may look like a correlation, but it is probably not the correct correlation. It's important to be clear, and the basis of this is one of the things, those themes you've heard from me over and over again is, what kind of data are you working with? What this chart shows is there's different kinds, with different kinds of data, you need different kinds of correlation types. Again, Pearson's R, which is just the plain R, which what you see here most commonly, that's the one that in 95% of what you're going to see in literature and things like that, that's what they're working with is Pearson's R. However, if you were trying to correlate data that was quantitative with ordinal data, you would use a biserial correlation. And it's computed somewhat differently because the data underlying it is different. I just want to note here, it's like if you're doing quantitative with ordinal, however that is, and this the Pearson's, the biserial is here as here, because these are sort of matched pairs. A biserial correlation, well, let me give you an example. What would be a situation where you want to do quantitative with ordinal? Suppose what I wanted to do was I wanted to correlate your current income, quantitative data, with your class rank in your high school when you graduated from high school. That's ordinal data. If I wanted to correlate those, to develop a correlation between those two things, I would use a biserial correlation as opposed to a Pearson R. Suppose I wanted to correlate income, again, quantitative data, with whether or not you own a house, whether or not people, groups own a house. Well, whether or not you own a house is nominal data. It's dichotomous nominal data. But what you would use that is a point biserial correlation as opposed to a biserial. Different kind of correlation. The mathematics of it are different, but it gives a more accurate measure of what the correlation is. These, in every one of the correlations, what there is there are some underlying assumptions about the data. And what I'm pushing some here to look at is, for what it, instead of doing the mathematics and sort of walk through the mathematics, which gets into number theory and ring theory and some of that stuff about it, I just want to say, I want you to be aware that if you need to be thinking about the kinds of data, I keep harping on this issue, because what it does is it tells you what kind of correlation you should be using if you want to do some computation. If you want to do a correlation between two types of ordinal data, you'd use a Spearman-Rho or a tetrachoric R, which gives you, those are things between two types of ordinal data. Example of two types of ordinal data. Suppose I wanted to do a correlation between your high school graduating rank and your college graduating rank. Both those things are ordinal data. The appropriate technique for that would be the Spearman-Rho. That'd be the one that's used most commonly in the process. Rank biserial, if you're doing ordinal with nominal, using these things I've used so far. If I want to correlate your high school graduating rank with whether or not you own a home, that's, or whether or not you own a home is nominal, high school rank is ordinal. You use the rank by serial correlation. And potentially if you want to correlate nominal with nominal, you'd use phi or L or C lambda. I mean, this is a fairly rare one, but it's like a case where you would do that. Maybe I wanted to correlate gender with home ownership. You could use that. This would be the correlation, the type of correlation you would use for that. I would have included these things mostly because I want you to be conscious that there are different kinds of correlations depending on the kind of data. And that's the crucial thing here is, it's why I start with this. I know walking through the stuff on types of data, the first chapter, gets people crazy. But the reason I do it is because, again, this is one of those places where it's like, well, depending on the kind of data, it depends on what tools you use. And you got to be conscious of data to choose the correct tool. You use the wrong tool and what you get's garbage. I'm not going to test, I may put a question in or so about if you were doing this type with this type, which type would you use? And then if you see that kind of question, go right back to that chart and sort of say, okay, it's one of these with one of these, so it'd be this one here. I think in the Excel statistics add-in, there's opportunity there to use other kinds of correlations. I'm not going to do that with you here. And if I'm going to ask you to do a correlation, it's always going to be a Spearman's R. That's what my assumption. You believe that with me. I'm not going to try to trick you on this. I'm including this mostly just so you have a sense of what are the different kinds and what happens, how you should be adjusting your own thinking if you're doing some work and you have different kinds of data. That's all.